the goal of this video is to very quickly give you an overview of what an LLM is. There are many great resources on that, including the reading by Stephen Wolfram and the what is a GPT video that you have assigned for this week. But like I said, I am going to try to very briefly guide you and just give you a few points to keep in mind in what is a large language model. So as you know, large language models, or LLMs, are the prevailing architecture and kind of AI system that is currently very widely used and finds many different applications. And the LLM is based on the transformer architecture, which essentially transforms one kind of input into an output, and it's all part of human language. What happens in between, because computers do not read natural language, is exactly this processing, this transformation of the information of the input in the way that you see outlined in this diagram here. So you start with a token. A token is a little piece of human language, of natural language as we call it, and a token is a little piece of it, which means it's something like a syllable. Then this token takes a token ID, and then, as I said before, because LLMs, just like all of computer programs, do not read, do not understand, if you want to use that term, natural language, we have to turn this into something the computer understands, which is math. And so the token will become one hot vector. We don't have to dive deeply into the linear algebra of this, but just make a note that that's just a mathematical concept, one hot vector. You may know what a vector is from math or physics courses. And then the vector, the one hot vector, becomes one embedding matrix, which becomes an embedding vector, which becomes the attention mechanism, which is a very important mechanism so that the LLM, the transformer, can operate this prediction making function that it does. Important thing to note here that what the LLM does is to predict the next token. Remember, we started from a token and that was our input, and we want to get to the next token. So what the model is going to do, and is doing through this process, is come up with the next token by means of prediction making. So we're here at the attention mechanism, and then we get to this layer. All these are different layers of the transformer architecture. This is the MLP layer, or some more linear math terminology comes up, a ReLU function, and the model destroys some information that it doesn't need, exactly so that it can predict the more likely information coming up, and then the unembedding logic, and then normalizing into a probability, and then sampling based on a technical feature that is called temperature, which helps the model select what the likely next token is going to be. Again, you don't have to remember every detail of this or understand all the mathematics behind it, but just know, importantly, that what the LLM does is predicts the next word based on the training data. So it's been trained, and these models are called base models. Why are they called base models? They have not yet been specifically tuned, which means we have not tried to make them do a very specific task. And that's what RLHF does. RLHF is the acronym for reinforcement learning from human feedback, which is exactly a procedure that allows for additional training so that the model can improve its performance for a very specific task. For example, trying to follow instructions to become a helpful, honest, harmless assistant, which is something that you might encounter when you're using models such as ChatGPT, where the model tells you as a helpful, honest, harmless assistant, and so on. This is what the model has been specifically fine-tuned to be. All right, so make a note of this architecture, and if that would help you, let's go see the more engineering side of this. Again, you don't need to know what this does or how it works, and you certainly don't need to do any programming. However, it's definitely important for you to keep in mind and take away as you leave this course and as you're going to be preparing for your midterm and final. You will be requested, perhaps very likely, to describe at the conceptual level what this transformer architecture is, exactly because it's this very popular architecture used in current AI. And imagine at this level of conversation, a friend of yours asks you, while you're taking this AI class, and everyone's using ChatGPT, what is this made of? Could you quickly explain to me? So what you're going to say to them is what I'm going to describe to you now. Well, you're going to say ChatGPT and models like it, they're called large language models. Their main task is to do next token prediction. They're meant to be predicting text correctly. The architecture they're based on is called the transformer. The transformer is made out of different layers. The layers are the attention, the embedding, the MLP, the transformer block, the unembedding, and like I showed you before, this becomes the MLP, the unembedding, remember here, and this becomes normalized, and the model is able to extract the probability that this token will appear next, and the token with the highest probability is the predicted token at the end. So this is what it would look like if you were to code this system from scratch. And feel free to let me know, or I will also put in the comments in the description section how would you be engineering a model like this from scratch. So what would you be telling your friend is that such a system has all these different layers, and it's a prediction making task that's meant to transform an input text into an output, the output with the highest probability, again through this mechanism of processing the text and trying to predict what the right output would be.